back, you guys, to your favorite intermediate algebra course. Let's take a look here today at arithmetic sequences and series. So if you look at this first question I have here, what is an arithmetic sequence? Can you see how in this first one, 7, 10, 13, 16, you notice the next, you could probably predict the next one's going to be, oh, it's going to be 19 because you see how it's going up by 3 each time. So that's our common difference, we call that. It has a common difference of 3. Okay, that is an arithmetic sequence. When you have, it's a sequence in which the difference between consecutive terms is constant. So it's going up by a certain amount, or maybe it's going down by a certain amount. Let's look at the next one here. 5, 0, -5, -10, -15. Of course, you know the next one's going to be -20. Can you tell that you're going down 5 each time here? Down 5. Getting smaller. So your common difference here is -5. Okay, those are both arithmetic sequences. Let's look at this first example and decide whether this sequence is arithmetic. So to do so, you want to test it. You want to say, well, let me take the second term. You know, this is A1, A2, A3, A4. Let me take the second term minus the first term. Let's see what I get. -1 minus the -4. It looks like that's -1 plus 4, so 3. Common difference of 3. That means this should go up by 3 each time. Let's take the third one minus the second one, and let's see if it gives us the same thing. 2 minus the -1. 2 plus 1, 3. Last test here. Does the fourth term minus the third term, 5 minus 2 gives us 3. Hey, looks like it works, doesn't it? Common difference 3, definitely arithmetic. Okay, it goes up by 3 each time. You can probably tell that without doing the little test, but that's going to help us out later. All right, how about this one? Second term minus the first, looks like it's 3. Is it the same as 9 minus 4? No, it is not. No. So this is not arithmetic. Can you see how it goes up by 3, and then it goes up by 5, and then it goes up by 7? So it's not a fixed amount that it goes up by each time. Okay? So that is not an arithmetic sequence. It's some other sort of sequence. All right, so here's a rule for an arithmetic sequence. Here's a way that you can figure out, if you remember last time we were kind of playing around with them and figuring them out intuitively. And we did that with quite a few arithmetic sequences. Well, guess what? There's a rule, and you can follow this rule to find what the formula is for the sequence every time. Okay? So, and this again, this only works for arithmetic sequences. So let's look at this. 49, 38, 27, 16, 5. We're trying to write a rule here for the nth term of the sequence. Okay, well, the first thing you want to do is you want to find the common difference. Okay, so you say, well, a second term minus the first term, 38 minus 49, looks like that's -11, right? So it's going down 11 each time. Can you see that? Down 11, down 11. So note, first step here, find your common difference. My common difference is -11, okay? So that's the first thing that we need to figure out is the common difference for this formula. Now the other thing is, what's the first term? You notice in the formula up there, you need to know the first term. What is the first term? Well, the first term's 49. Okay, now we can write it. Okay, according to our little, rule here, we can find an nth term by plugging in D and plugging in the first term. So a sub n equals 49 plus n minus 1 times the common difference of -11. Okay, let me clean that up a little bit. So we got 49 plus n minus 1 times the -11, and I distribute that. 49 minus 11n plus 11. 49 plus 11 looks like we got, what, 60? And usually you'd write that -11n plus 60. That's your nth term. So if you plugged in like 2, for instance, into this formula, if you're trying to find the second term, what's 60 minus 22? Well, that's 38. Guess what? That's your second term, isn't it? So this nth term formula will find you all of the terms that you need, okay? All right, let's look at the next example here. We got one term of an arithmetic sequence. So we got this seventh term is 5. We know our common difference is -7. Write a rule for the nth term, okay? So if you're trying to kind of try and make this thing visual, you're like, hey, I know that seventh term is 5, right? And the common difference is it goes down 7, right? So 5 minus 7. If it goes down 7, you know your eighth term here would be -2, then it'd be -9, and so on. And you could keep going with that, right? We're trying to write a rule for the nth term. So first step, well, we know the common difference. That's nice. They gave it to us, okay? Now, second step is how can we use this seventh term that they gave us to figure out, because we need the first term when we're writing this thing, okay? So what we do is we say, well, I know my seventh term, so if my n is 7, right, you see the n is 7 here, a subscript 7, so n is 7, I know my common difference, I'm going to plug these in, common difference is -7, and what is my seventh term? Well, my seventh term is 5. But I wrote that so you'd recognize that my n is 7. So we got 6 times -7. And all of a sudden, when I plug this in, I can find my first term. 47 is my first term. Aha! Now we can plug it in and find the rule. So we plug in D, we plug in the first term, and we'll leave it in terms of the nth term. Okay, so the first term we just figured out was 47, right? That's what this is right here, 47, first term. It goes down 7 from there, and that's why you end up with 5 on the seventh term. N minus 1, our common difference here is -7. We go ahead and distribute that. And I prefer to write it -7n plus the 54. Plus 54, good grief. 7n plus 54. There's our rule for the nth term, so we could figure out any term that we wanted to after that. For instance, if you found this eighth term, you know how we already knew that the eighth term was -2. A subscript 8, eighth term. So that's a -56 plus 54. Look at that. It gives us the -2. It gives us instantly the eighth term, which we'd shown there before. Okay. So what if they give you 2 terms, okay, but no common difference? So 2 terms in arithmetic sequence are given. The 7th term is 20. The 23rd term is 52. And we're trying to find a rule for the nth term, and then the value of n, for which the a subscript n, so a whatever term that is, ends up being 44, okay? So let's start with part A here. Let's write this rule first. So I'm going to write, first of all, I have this a subscript 7 is 20. Let me use the formula here, and let me plug in 20 for my a subscript 7, right? So my 7th term. Now I know my 7th term is 20, so 7 is my n. Okay, so I have, you see how I have an equation there? 20 is a1 plus 6,2, but I also have this other one. A23 is 52. So if I plug this in, I'm going to have a system of equations, and I can use substitution to solve this thing. So my 23rd term, which my 23rd term is 52. I'm going to write that again so I know my n. Okay, now you notice 20 equals a1 plus 62, 52 equals a1 plus 22d. I have two variables, so two unknowns, two equations. So this is solvable. Let's solve this by substitution. So if I subtract 6d here, let me undo those lines. That's bugging me. Okay, so subtract 6d, both sides. So you notice 20 minus 6d is a1. a1 20 minus 6d. So let's go ahead and plug that in for a1. Okay, so over here we have 22d. I didn't finish that, did I? Okay, so 52, I'm solving this by substitution, equals 20 minus 6d. That goes in for a1. And then I got this plus 22d. Okay, so I got 52 is 20 plus, what's that, 14, 16d. Okay, subtract 20. 32 is 16d, divide by 2, 16, and you get 2. So our d is 2, all right? Great, we know that. D is 2 now, and now, once we have that, let's go step 2 here. Now we know D is 2. So I'm going to use this, and how about that one right there? A1 is 20 minus 6D. So now I can find my first term. So I need my first term, and I know I need my D to write the rule. So we got 20 minus 12. We got 8. So our first term is 8. So finally, we know D is 2. Our first term is 8. Now we can write the rule. Distribute that 2 there through to each of those. And I like to write that 2n plus 6. There's our rule to find any term that we want. So last step here, it says find, so this is part B, find the n such that, what was it, find n for which a sub n equals 44. Find n such that a n equals 44. So as you might expect, we're going to use our rule here. And we know an is 44. We know it ends up being whatever term that is, it ends up being 44. We just need to find the n for it. So get a little room here. Oh my gosh. Arithmetic's struggling today. So 19 is my n. That's my n. In other words, you know how they said the nth term is 44? That means the 19th term is actually 44. Right? Okay, good problem there. Let's move on here. The sum of an arithmetic series. Okay, so now you got a formula to calculate a sum right away. As long as it is an arithmetic series, okay? So let's consider the arithmetic series here, given right there, 3 plus 8 plus 13, 18, 23, and so on. Find the sum of the first 40 terms, okay? So let's do part A. Now I'm going to go ahead and write this first. Okay, the sum of the first 40 terms. So 40 is my n. 40 is my n. Now we plug in. So I say, well, what's the first term? Well, luckily, we know the first term, right? It's 3. Sometimes you have to figure that first term out. Okay? A sub n. They're like, oh, we don't know a sub n. Okay, I got to fill that in. Figure out a sub n, then we can plug it in, we can figure this thing out, okay? So now we got to go to the side and we say, well, let me extend this a little bit here. This thing, 3, 8, 13, do you notice, first of all, so find the formula, find the nth term formula here. You notice your common difference, it goes up by 5, right? And we know our first term is 3. So we can write this formula now. So the nth term is 3 plus n minus 1 times d, which is 5. So the nth term is 3 plus 5n minus 5. And the nth term is 3 minus 5, negative 2 plus 5n, or 5n minus 2, right? Now, what we're looking for is a subscript n. Now, you remember our n is 40, right? N is 40. So we're looking for here, oops, I'm sorry, I think I said the rule there. We're looking for the 40th term, aren't we? Okay, so now that we have the rule, so we needed the rule to find the 40th term, we just plug it in. So we say, oh, well, that's easy. The 40th term is 5 times 40 minus 2. So 200 minus 2, 198 is our 40th term. Okay, that goes right here. So the sum of 40 terms (201 over 2), and you know what? I'm going to go like this. I make that 20. 401, what's that? 802, I believe. 402. Goodness, I should be punching these into a calculator. I'm so bad today. I think that's what it is. That 4020 there. 20 times 201. So that's the sum of 40 terms there. Okay. Now, if I'm looking here for, let's see, part B, find n such that the sum of however many terms is 570. Okay, find n such that the sum of those many terms is 570. Let me extend this a little bit. So you want to write out, go ahead and write out the sum formula. Let's see what we can fill in here. Okay, so there's our there's our formula. So that we know the sum of n terms. We don't know what n exactly is, but we do know it ends up being 570. So we fill that in. Say, I don't know n, right? I'm looking for that. I do know the first term, which was 3. I don't know a subscript n, but I do know I mean, we don't know what term that is. We don't know the nth term, but we have the formula, right? So I go back up to my formula right here, 5n minus 2, and I'm going to write that in. So what that does is it makes it solvable now. Okay? So we just keep going on this thing and simplify, solve for n. So we got 3 minus 2 is 1. So 5n plus 1 all over 2. You go ahead and distribute that. 5n squared plus n all over 2 is 570. Multiply both sides by 2. Let's get rid of that. So we got 0, 4, 1, 11, 40 is 5n squared plus n. Go ahead and we subtract 1140 from both sides. And then let me bring this up over here. Okay, so we got 0 is 5n squared plus n minus 1140. And at this point, you're like, well, hopefully I could factor that, right? Or I could just plug it into the quadratic formula, okay? I'll just give you the factorization on this thing. This actually factors into 5n plus 76 and n minus 15, okay? And then you solve each of those, so your n is 15 from this one, And then your n is actually negative 76 over 5 from that one. Well, you can't have a negative 76 fifths term. Okay, so it ends up being 15. You know, frankly, if I was doing this, I would have just plugged this into the quadratic formula. So n is negative b, your b is 1, right? Plus minus square root b squared minus 4 c all over 2 times a. And then this works out dot dot dot, you know, whoops, dot dot dot, n equals negative 76 over 5 or 15, and you would throw that one out. Okay? Kind of a messy problem here, but the whole idea here is you plug in the 570 because you know that the sum of n terms is 570. You plug in the formula right there, and then you just kind of chip away at it, solving this quadratic. Okay? Thanks for listening, you guys. We'll see you soon.